Okay, so now we're going to do a delta epsilon proof for a quadratic function. So our quadratic function, we're going to do x squared plus x, and we'll take the limit as x approaches 3. Now, what we want to show, right, the proof part is we want to show that for x minus c less than delta, we're guaranteed that our function minus the limit will be less than epsilon. Okay, so let's go ahead and let's find our limit value, and then we can decide, right, what each of our parts is. So as x approaches 3, our limit, right, we plug the 3 in, we'll get 9 plus 3 is 12. So our limit is 12. So what are the different pieces over here, right? So x approaches c, so as x gets close to 3, right, our function gets close to the limit. Okay, so we need to, well, we're going to start with the function, the L and the epsilon, and then look for that relationship between delta and epsilon as we search for this x minus c. So let's go ahead and write those out. So we're looking for an x minus 3 using, right, less than delta, using our function minus the limit less than epsilon. So we're going to start with our function part, work our way back to our input part, right, and then undo all of that. Okay, so we're going to start with x squared plus x, f of x, minus L, less than epsilon, and then we're going to keep our eye open and look for this x minus 3 less than, right, this delta. That's going to be our relationship we're looking for. So factor, in your parentheses, so let's see, x plus 4 times x minus 3 less than epsilon. We can break apart, right? The absolute value of a product is equal to the product of the absolute values. And hey, there is our x minus 3, right, that we were looking for. But we also have this x plus 4 that we don't have, right, we can't just get rid of it because we don't know how to bound it yet. So the next thing we need to know is how do we put a boundary on that x plus 4. So here's where it gets just a little bit weird. I'm going to go ahead and go back to our x's here, x minus 3 less than delta, and I'm going to put a boundary on that to start with. So we're going to let delta equal 1, just because it's an arbitrarily small number. If delta equals 1, then, right, absolute value of x minus 3 is going to be less than 1. Solving that absolute value inequality, right? The 1, if you think about the pluses and minuses in inequalities, or you can trust me on it. So, right, x minus 3 then is between plus and minus 1. Solving that for x would give us 2 is less than x. I'm going to leave a little space because I'm going to come back in there, right, is less than 4. But, right, what I really needed a boundary for, right, was this x plus 4. So if delta is 1, right, then I know x is going to be between 2 and 4, which means that x plus 4, now add 4 everywhere, right? That tells me that that x plus 4 is going to be between 6 and 8. Or, right, I just need to know, right, the upper boundary for it, and so that upper boundary is 8, right? So for a small delta, for delta of 1, the most that this x plus 4 can be is 8. So I'm going to go ahead and replace this x plus 4 with an 8. So now I have 8 times the absolute value of x plus 3, I'm sorry, x minus 3, is less than epsilon. Scooch, 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 scooch. So there, right, now we're looking like, right, the thing I needed, this x minus 3 less than delta. So I'm going to divide both sides by 8, which will tell me that x minus 3 has to be less than epsilon over 8 or 1. Okay, so now I have that relationship between delta and epsilon, right? Delta equals epsilon over 8 or 1. So here's, right, kind of hand wavy. We're going to let, so here comes the proof. Now we're working it backwards. We're going to let delta equal the smaller of 1 or epsilon over 8. We can show that if x minus 3 is less than, right, delta, either 1 or epsilon over 8, whichever one is smaller, then our function, I'm sorry, plus x, sorry, can't see up there, minus L is going to be less than epsilon. Okay, so go ahead and replace the delta with the epsilon over 8. So value of x minus 3 is less than epsilon over 8. Multiply both sides by 8. I'm not taking the 8 inside the absolute value like we did when it was linear, because now I'm going to look kind of back up here, right? And I know that x plus 4, right, is always going to be less than 8 as long as, right, delta, right, the most it can be is 8 if delta was 1. So my caveat before I started my proof was that delta was 1 or, right, the smaller of 1 or epsilon over 8. So that means this 8 here can get replaced with x plus 4, right, because delta equaling 1, right, the most that could be was 8, and it's less than 8. So this 8 can get replaced with absolute value of x plus 4 times the absolute value of x minus 3 less than epsilon. And now we're sort of, right, we've kind of done the proof, because after that it's just really reworking it backwards. So take these guys inside the same set of absolute value symbols, multiply them together, oh gosh, plus x minus 12, and then split them apart, right? Because what we wanted to show, that f of x minus L, right, is less than epsilon, so we need to pull out the f of x squared plus x, and then the minus L. Oh, never mind, it's already there. I didn't have to pull it apart. Ta-da!